What do you do when you find someone basically giving away solid cherry lumber? I'll tell you what you do. You buy as much as you can fit in your car and you build something with it. I became inspired to build a Japanese style trestle table after watching the Kigumi table video by Ishitani Furniture. I designed a smaller version of this table myself, and I built it with a combination of power tools and hand tools. The table top is only 3 feet by 2 feet, and I designed it to fit in the breakfast nook area of my kitchen. I purchased a few 8-foot long, 5/4 thick cherry boards that were all between 5 and 7 inches wide, and according to the seller, they had been sitting in a climate-controlled area for over 20 years. I started the build by focusing on the table top. After cleaning off some dirt with a wire brush, I used my miter saw to cut the boards to rough lengths. The next step is to joint and plane the boards to get the faces perfectly flat and square. Some of the boards were wider than my 6-inch jointer, so a small amount is left rough on the side. There are some tricks to deal with this, like using a special sled to support the board as it passes through the planer, but I decided to just clean off this edge with a hand plane. By referencing the bed of the plane on the already jointed area, I was able to get this flat enough to stably pass through the planer. By flipping the boards over and taking several passes through the planer, I fixed any slight inaccuracies created by my hand planing. Next, I jointed one edge of each board. I decided to plane both faces before jointing any edges because the lumber was so old and dirty that I couldn't clearly see the grain direction. It's important to pass the boards through the jointer in the correct grain direction to avoid tear out and get a clean cut. I finished the milling process by cutting the final edge parallel on the table saw. Since the table top is made from 4 boards glued together, I took my time deciding what orientation the boards should be. I tried to get the grain to visually match as much as possible to hide the seams, and also tried to alternate grain directions as much as possible so the top remains flat as it expands and contracts with the seasonal humidity changes. The glue seams weren't lining up perfectly, so I ran the boards 2 at a time over the jointer in opposite directions. Using this trick helps fix any slight alignment issues with the jointer. If one edge isn't perfectly square, the matching edge from the other board will be out of square in the opposite direction, so the alignment problems will cancel each other out. Since I don't have a Festool domino or a biscuit jointer to help keep the boards aligned during the glue up, I added some clamps along the seams to try to keep the surface as flat as possible, which worked pretty well, but wasn't perfect. Once the glue dried, I scraped off any excess and went to work with my hand plane to get the entire top perfectly flat. I cross-cut the table to final length with my Festool track saw. Just kidding, I can't afford one of those, so I clamped a level to the table and used my circular saw instead. With the tabletop flat and square, I started working on the legs. The vertical pieces are joined to the horizontal ones with a bridle joint, which is sort of like a mortise and tenon joint, but is legally binding and comes with some tax benefits. I milled the lumber for the legs in the same way as the tabletop, so I'll skip over that bit. I used my crosscut sled and a stop block clamped to my table saw fence to cut the 2 legs to exactly the same length. To cut the mortise half of the bridle joint, I modified my spline cutting jig to hold the leg vertically as it passes over the table saw blade. I cut this in one pass with the blade at full height, which pushed the limits of my saw. In retrospect, I probably should have taken multiple passes, slowly raising the blade height each time. By sliding the fence over slightly between passes, I was able to cut out all of the material for the mortise. To cut the tenon half of the joint, I placed the horizontal component of the leg between 2 stop blocks on my crosscut jig and hogged out the material with about 1,000 repeated passes on my table saw. This would be faster with the dado blade, but I don't have a jig for that, and I'm too lazy to change the blades anyway. After a quick test fit, I could see that the joint was fitting together pretty snugly. To cut the angles on the horizontal pieces, I marked them with a ruler and cut them out roughly with my bandsaw. Afterwards, I cleaned up the rough edges and made the cut more precise with my hand plane. The bridle joint came out really clean and is tight enough to hold together on its own. That means that only a small amount of glue is going to be necessary to make this joint permanent. There are a lot of ways to attach the legs to the top, like sliding dovetails or special fasteners. Whichever method you use, it's important to take into account the seasonal wood movement of the solid top. I opted to use some screws in widened holes. This is the method that the wood whisperer used when he built his trestle table. By allowing the screws to wiggle a little bit in the grain expansion direction, the top can move a few millimeters freely while having a solid connection between the legs and the top. Before gluing the legs up, I cut some quick chamfers in the areas that will be hard to reach once the legs are assembled. The chamfers are mostly there to make the table more comfortable to touch with your hands, but the chamfers along the feet where the table touches the ground are especially important to prevent chip out when this table gets pushed around across the floor. The leg glue up was pretty straightforward, requiring only 2 clamps per leg and a square to make sure the horizontal pieces are correctly aligned. While the legs dried, I went back to work on the table top. I decided to cut an angled bevel around the underside of the table to give it a classier look. This is one of the advantages of designing a piece in 3D modeling software like SketchUp before building. I was able to toy around with different sizes and types of bevels on the computer until I found one that I really liked, before actually making any cuts. I marked out the bevel depth with a marking gauge around the outside edges and traced the full depth on the underside. I used my hand plane at an angle and slowly approached the lines. It's important to first cut the bevels along the long edges of the table, working with the grain, before cutting the cross-grain ones. Working in this order prevents tear out that would happen if you tried to start with the cross-grain. Using hand tools like this makes woodworking feel more like an art than a science, and I've been trying to work more hand tools into my projects lately. If you haven't checked out the YouTube channels by Paul Sellers or Rob Kosman, I really recommend those. They're the two that got me really hooked on hand tools. The last ingredient in the recipe for a trestle table is the cross piece that connects the 2 legs. I decided to use a wedged through tenon joint for 2 reasons. It's very structurally stable, and it looks awesome as hell. After cutting the cross piece to length, I cut the tenon on each side by again using a stop block on my table saw crosscut sled. With the tenon cut, I can mark out the spot for the mortise on each leg with a knife. I removed most of the mortise waste material on my drill press with a Forstner bit, then cleaned up the edges by hand with a chisel, working from the outside of the leg inwards, since the outside will be much more visible than the inside once the table is fully assembled. Here's where I made a pretty big mistake. Can you spot it? I had laid down a towel on my workbench to try to avoid creating any dents in the legs when marking the mortises earlier, and I forgot to remove it. Since the towel is soft, when the chisel passed through to the other side of the leg, a huge piece chipped off with it. It's important to firmly support the back of the workpiece when cutting through it for this exact reason. Fortunately, I was able to glue the chip back in pretty well, and most of the ugliness is covered up by the shoulder of the tenon in the crosspiece. After some trial and error test fitting the joint, I eventually got it fitting pretty well. Since the wedges will be driven into the end of the tenon, causing it to expand, the mortise should be a little wider than necessary and angled slightly inwards. Speaking of wedges, I cut the slot for them into the tenons on my bandsaw and drilled some small holes at the base of each slot on my drill press. These holes are there to help the tenon to expand comfortably when the wedges are driven in without cracking. For the wedges themselves, I used some scraps of purple heartwood that I had lying around, and I sanded them into a triangle shape on my belt sander. After some quick sanding of the table components with 220 grit paper just to remove any pencil marks, I can finally glue up the entire leg assembly. As you can see, the crossmember fits a little loosely into the mortise hole, but once the wedges are driven in, it holds firmly on its own. I added some clamps for good measure while the glue dried, but they aren't really necessary here. Next, I cut the Purple Heart wedges flush and sanded down the exposed tenon to remove any potential glue stains. For a final finish, I used multiple coats of Armor Seal satin, wipe-on polyurethane, sanding very lightly with 400 grit paper in between coats. This process took me about a week because I had to separately finish the underside of the table and the top of the leg assembly to make sure that there was dried polyurethane finish on those surfaces when they get screwed together. After a few days and coats of finish, I screwed the leg assembly to the tabletop. I used an awl to mark where the screws will go, and I pre-drilled the holes in the underside of the table with a bit slightly narrower than the screws. The piece of tape on the drill bit tells me when to stop drilling, because accidentally drilling through the top of this table would be pretty devastating at this point. To cover up those ugly screw holes, I used a plug cutting bit on my drill press into a piece of scrap cherry that was left over. By matching the grain direction of the plugs with the underside of the legs, they hide pretty well. Also, anyone using this table would have to try pretty hard to ever see that surface anyway, so I didn't worry too much about this. I planed and sanded the plugs flush, then started applying finish to the leg assembly. I ended up using 3 coats on the legs and the underside of the tabletop, and about 6 coats on the very top surface, since it's going to take the most wear. I'm super happy with how this table turned out. Thanks for watching.